Hello, let's do the New York Times Medium Sudoku for May 28th, 2024. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, for the mediums, I do take it a bit slower, and I take a more systematic method to the solves as a learning tool. So take what you will out of this solve, but not only am I going to solve the puzzle, but I'm going to explain the techniques as I go, in case you haven't seen them before. So we're going to start with terminology. These are cells. It's a 9x9 grid of cells. That's the sort of most important part of Sudoku. And so there's 81 in total. And each cell will end up with a digit between 1 and 9 placed in it. We have been given some already, which is why we call them givens. And the givens are what make the puzzle. If we were just given a blank Sudoku, we could just pretty much randomly fill digits and usually end up with a solution. There are a ton of possible solutions to the blank grid. But by being given specific digits, the way they've been given, it causes the solution, or it causes the Sudoku to have only one solution. There's only one way that we can fill the rest of these cells with digits between 1 and 9, such that it fulfills all of the Sudoku rules. And that's what makes it a puzzle as opposed to a guessing game or a gambling game. So we are not going to be guessing where digits go. We're not going to go, well, I think a 1 might be able to go here. So yeah, it seems fine. All right, for now, let's keep a 1 in there. We're not going to do that. We are going to use specific logical techniques to prove whether or not the 1 can actually go there. And by proving as we go and being 100% certain, we can fill in all the digits without mistakes. And it is a mistake to fill a digit that doesn't belong there. And I would also consider it a mistake to fill a digit when at the time we didn't know that digit had to be there, even if we happen to be correct. All right, so what are the Sudoku rules? Well, we have rows. A row is a horizontal line of 9 cells. And digits, we're placing the digits 1 to 9 exactly once each. And because there are 9 cells, that means we're not going to omit any digits from 1 to 9, and we're not going to repeat any digits from 1 to 9. So exactly one of each of 1 to 9 in every row. So there are 9 rows. So we're going to end up with 9 of each digit. Same for columns. There are 9 columns, and each column we're going to have 1 of each digit. So the columns also say there's going to be 9 of each digit. And then we also have these 3x3 boxes that are denoted with bold outlines. Only the ones with bold outlines. So like this 3x3 here does not count as a box because it does not have a bold outline. There are 9 boxes in the grid as well, and we're going to be placing 1 to 9 in each box. And so the boxes also say there's going to be 9 of each digit. So I think it's pretty safe to conclude from 3 different pieces of evidence that are logically sound that we're going to end up with 9 of each digit in the grid somewhere. And we're going to be following those restrictions of the rows, the columns, and the boxes. So for example, as a result, this 2 that we were given here, we can conclude that there's not going to be another 2 in this row, there's not going to be another 2 in this column, and there's not going to be another 2 in this box. So you're going to get a shape like this, where every digit's going to exclude itself, whatever digit it is. So in this case, the 2 excludes 2, or eliminates 2 is usually the word we might use, from every other cell that I have highlighted here. And it's gonna usually be 8 for the row, 8 for the column, and 8 for the box. But you can see there's a little bit of overlap between the rows and the columns in the box. So it's 4 additional from the box. So 8 plus 8 plus 4, that's going to be 20 cells. So every given eliminates that digit from 20 other cells. Okay, cool. So as you can see, you need to find overlaps between rows, columns, and boxes oftentimes in order to determine where a digit can still go. We also use the word looking a lot, and I realized I haven't explained that before. And the preposition I use afterward is a little bit arbitrary. So I might say this 2 looks right and eliminates 2 from the rest of the row. I might also say it, I wouldn't say it looks left because I would probably use the box for that, but it does look left as well. So we can pick a central digit like this 5. This 5 looks up, down, left, and right, and it also looks in the box. But I might say that this 5 looks into this box, right? Because if I'm focusing on this box, I would use the word into to say, hey, the 5 looks into here, eliminating 5 from these. But you could also say the 5 looks left, eliminating from these. But I think the word into is more natural when I'm focusing on this box and I'm saying, hey, this 5 looks into it, right? This 4 looks into it. This 2 looks into it. So So my choice of preposition is based on my perspective of what I'm currently focused on. But look is the important thing. Look means, hey, it's eliminated. And I usually try to only to use the word look when we have a placed digit doing it. If there's some other reason that the elimination happens beyond placed digits, then I'll use a more appropriate term to why that elimination happens. So I might say it points in, or it claims, for example. Or I might just say there is a pair that eliminates. That's my terminology there. So I thought I'd spend a little bit of time. Apparently I've spent about 5 minutes of time explaining that. Hopefully that's helpful. I can't spend every single video explaining the same things every single time just because of time constraints, but I thought I would spend that time because I did get questions about it yesterday. I've tried in the past just making a video and saying, hey, here's the video that explains everything, but the problem is that these videos are very short-lived in terms of views because of the date. And so I find repeating myself is a much more effective strategy because I'm constantly getting new people. All right, so bear with me here. That is terminology that we're using, and that is the Sudoku rules. Hopefully that clears things up that you may have had questions about. Finally, 2 terms that are going to be important for our initial pass of scanning, and also just good terms to know. These have nothing to do with the Sudoku rules necessarily, but they are useful structures. So when we have a row of 3 boxes, we call that a band. You can kind of think like a band around something, or like a belt, right? So this is called a band, just a row of 3 boxes. A column of 3 boxes is called a stack. So there are 3 bands and 3 stacks in the puzzle. So let's think about bands. Now you can kind of imagine bands and stacks are basically equivalent because you could rotate the puzzle 90 degrees. Your rows and your bands would become columns and stacks, and your columns and stacks would become rows and bands. And then you can rotate 90 again and they'd switch back, right? So it doesn't really matter. They behave the same, but because we on a computer especially, our perspective and also the orientation of the givens and the digits we place, our perspective has a specific up, left, and right. And so as a result, it makes sense to talk about those directions and to distinguish bands from stacks so we know what we're talking about. All right, so we call this like band 1, band 2, band 3. You know, we always count left to right, top to bottom. So stacks go left to right, 1, 2, 3. All right, that terminology. So let's think about bands for a second here. How many of each digit are we going to have in a band? Well, similarly to how I proved it for the whole Sudoku, a band is made up of 3 rows, and each row will have 1 of each digit. 1 times 3 is 3. So because each row has 1 of each and there are 3 rows, we should end up with 3 of each digit. We can also prove it via the boxes. The band is made up of 3 boxes. Each box has 1 of each digit. So therefore, we will end up with 3 of each digit in total in the band. Now, for example, this 7 here, I'm going to make those green for a second. The green 7s here, we have found 2 out of the 3, or we've really been given 2 out of the 3 7s in this band. So we know there's going to be a third 7 somewhere. What can we say about where it's restricted to being? Well, the first thing we might notice is that we have a 7 in row 1, and we have a 7 in row 3, but we are missing the 7 in row 2. So I'm just going to use purple here and say, well, row 2 is going to need a 7. So we better place the 7 somewhere in row 2. But also, box 2 has a 7 already, and box 3 has a 7 already. So the 7 better also be in box 1. I'll make that blue. So the result here is if I try to put a 7 anywhere but in where it's both blue and purple, then I won't have fulfilled both requirements of it being in row 2 and in box 1. So I actually am not allowed to put the 7 in any of these cells. I can only put it in these cells that are both blue and purple. So the 7's going to end up in one of these 3 cells. We've just proven that in kind of a nice like overview, holistic methodology here. But there's a little bit of an easier way to kind of show that, and we call that scanning. Basically, what we do is we focus on this box, and we say, well, we know this box needs a 7 because it doesn't have one yet. And then we look around and we say, okay, this 7 here, it looks into the box, and this 7 here looks into the box. Remember, I'm using the word look because it's a place digit, eliminating 7s from the rest of its row, column, and box. I'm using into because I'm focused on this box, and so I'm thinking about how the 7s are looking into it and eliminating from that box. I find that useful rather than switching up between this 7 looks left, this 7 looks left. I think into is just, it's implying no matter where the 7 is, as long as it looks into the box and eliminates, that's helpful. So we end up with the same 3 cells that need a 7. A little bit simpler to kind of conceptualize and to scan as we go and just do over and over again. Now, we know the 7 needs to be in one of these 3 cells, and there's no help below it. There's no other 7s looking in to help, so we don't know which of these ends up a 7. Again, we are not going to guess. I'm not just going to pick one and put a 7 and hope for the best. I have a 2 out of 3 chance of guessing wrong and breaking the puzzle with my very first place digit and not being able to solve it. That would be very frustrating. So, but we do want to remember that we've discovered that 7's in one of these 3 cells. And that, oops, I didn't mean to do that. And that's where notation comes in handy. So Sudoku Pad has 2 notation modes. It has corner marks and it has center marks. You can see corner marks go in the corner, center marks go in the center. They're aptly named. So I'm going to use the corner marks to always mean that within a box, always a box, never a row or column, within a box, we have limited that digit to the cells that are corner marked. So in this case, 7 is limited to these 3, and the corner marks are reminding me of that. So I don't need to remember that because the notation is helping remind me of it. And I always use the notation to mean the same thing. So I don't have to remember, oh, why did I put a 7 in there? Because for years, I've always used corner marks to mean the same exact thing, which is that 7 is limited in the box. We'll use center marks for something else, and I'll explain it when we get to it. So I'm just going to leave those 7s there. Now, we're only going to corner mark if a digit has been reduced to exactly 2 places in the box, then we'll corner mark it no matter what. If it's reduced to 3 places in the box, only if they share the same row or column. All 3 of them are just in a line. If it goes around corners or things like that, we are not going to corner mark that. At least not in classic Sudokus. All right. Not in these Sudokus. So, what we want to do is we want to find all of the repeated digits in the band. We don't want to just be like flicking our eyes back and forth and hoping to find them all. I recommend a systematic search, and it doesn't take very long. So we just need to compare box 1 against box 2, box 1 against box 3, and box 2 against box 3. We can make it even faster by starting with the box with the fewest givens. So we start with this 7. And we look for a 7 in this box and a 7 in this box. And you notice we do find the duplicate 7 that we already did. So this is when we would have done that. Then we've already done 2 out of the 3 comparisons. We've done this box against here and this box against here. So we just need to do the 2 other boxes against each other. Pick the one with the fewer givens, 2 and 4. Look for 2 and 4 in here. We don't have any. So that was the only other, there was only one repeat, which was the 7. We're now confident in that without having to figure out how long do I need to stare at the band before I'm confident I found everything. Instead, you just do it systematically and now, you can move on. So, but before we move on from this band, there are 2 other things I want you to look for. The first thing is when a box row has been filled. A box row is just a row within a box. So it's the intersection between a row and a box is a box row. So there's 3 box rows per box. And a filled one would mean we know what all 3 digits are that go in the box. So in this case, we know the 5 and the 8, but we don't know what this 3rd digit is. So that's not a filled box row. And so we don't have any of those. So nothing to do with that. And then also rows or boxes that have been reduced to 4 or fewer cells. We don't have any of those either. For example, this box is down to 5 cells. Now there is something else I am noticing here, which is this 2 is actually doing something interesting in this box. We're going to skip that for now. We're going to be looking for stuff like that in a second pass because it is a little bit harder to spot those things. If you do see it, feel free to use it. I'm not going to use it here because I'm going to assume that you're following my systematic method and did not notice that. Because I notice a lot of things about the puzzle that often I don't even bring up just because I don't want to overwhelm you with like, oh, was I supposed to have found that? And then it changes the solve path from how you would have done it. So if you follow my systematic method, ideally, my solve path will match yours. And so then you can use as a learning aid of, oh, we diverged at this point, which means I missed this thing that I was supposed to notice. And so if I start doing things like, well, I noticed this random thing, which isn't part of our method, then now my path diverges at that point and you won't be able to compare your solve. So following along might be more difficult, and applying it to other puzzles might be more difficult. So in the hard Sudoku solves, I absolutely would use it. I use anything I see to an extent. All right. So we have finished with this top band. Those are the 3 things we look for. We look for duplicate digits. I call them buddies because I think that's fun. It's like a buddy for this 7, right? Filled box rows. There's a specific thing we do when we find those, but we didn't find any. I'll explain it when we do. And rows or boxes down to 4 or fewer digits. Again, we didn't find any. I'll explain what we do when we find those. All right, and then we move on to the next band. We do the exact same thing to every band in order. So I'm going to start with the box with the fewest givens in it. So the 5 and the 6. I'm going to look for 5, 6 here, 5, 6 here. I don't see it. So now I'm going to compare these against each other, and I'm going to use the 3, 8, 9, the one with the fewer, right? I only have to remember 3, 8, 9. I don't have to remember 2, 3, 7, 8, 9. I just have to remember 3, 8, 9. And I look for 3, 8, 9 in here, and I find all 3 of them. When I find all 3 of them, I start with the lowest digit first, just so I know which ones I've done, because I can go, oh, I just did 3. Okay, well, 8's next, right? So these 3s look into here. This isn't 3. There's no 3s helping above or below. So there's a 3 in one of these 2 cells. Now we can do the 8s. These 2 8s look in. There is an 8 helping up here. So 8's in one of these 2 cells. And then I have these 2 9s. These 9s look in. Notice I'm using the word in just because I'm focused on the box. So I don't care which direction the 9s are looking, just that they're looking into the box. I don't have any 9s here or here looking into the box, so we can corner mark 9 in these 3. All right, and that is all the duplicates. Now, do we have any filled box rows? We do not. We have a filled box column, but we'll take care of that when we do the stack. We're only looking for filled box rows, and we're looking for rows and boxes down to 4 or fewer. Now, here's where you may diverge, because I don't have a specific reason to do one over the other. But what we want to do is we want to be looking at the rows and boxes that are down to 4 or fewer. Let's start with this row. Hopefully we reconverge if you do it in a different order at some point. But this row is down to 4 digits, right? It's 4 open cells. So we know what 5 of the 9 digits are. So the remaining 4 go in the 4 cells that are open, because we're going to end up with every digit in the row. Now, what are those digits? I recommend just starting out by thinking about them one at a time. So we need a 1. We don't have a 1 yet, so we're going to need one. And what I'm doing is I'm looking around the grid for 1s that are helpful. Mostly I'm looking to make sure we don't have any 1s in any of these boxes. And then I'm also looking at the columns that line up with the open cells. And I'm looking for 1s. And I see this one and this one. And you can see that does take 1 out of 2 out of our 4 cells. But unfortunately, the 2 cells that remain don't have much in common. They share a row, just because all of these will share a row, but they aren't sharing a box, right? If they shared a box, that would be interesting. And if there was only 1 left, that would be interesting because we could place it. But unfortunately, the 1 doesn't do that. But I'm going to remember that 1 was reduced to 2 out of the 4. The next digit is the 4. I'm noticing this cell also can't be 4, so it can't be 1 or 4. That's getting interesting to me. And when I list off the numbers later, I'm thinking about that as we go, but I'm just very fast at scanning it. So the 1, the 4, and then we need 7, or sorry, I missed something. 1, 4, 6, and 7, right? So let's think about the 6, and we also have a 6 here. So here's where I trigger in my head. I go, wait a minute. This cell saw the 1, 4, and 6. So what we have here is called a naked single. Let me explain the naked single. So naked is a term that we use when we're looking at a specific cell and we're looking at how that cell is restricted based on Sudoku rules and other logic that we've acquired through the solve. In this case, it's just Sudoku rules, though. So what I'm looking at is I'm looking at this cell, and naked single, this word single is telling me that there's only 1 digit that this cell can be, so it must be that digit. So let's think about that. I'm going to make this cell green so you can focus on it. And I'm going to highlight digits one at a time, and I'll make them purple as we go. I think that's 5. Yeah, okay. So this cell, it cannot be a 1 because it sees this 1. It cannot be a 2 because it sees this 2. If there's more than 1 that it sees, that's fine. I'm just going to pick one. It sees this 3. It sees this 4, 5, 6, 8, and 9. That is 1, 2, 3, 4, 5, 6, 7, 8 digits. So this cell, just by normal Sudoku rules, cannot be 1, 2, 3, 4, 5, 6, 8, 9. The 1 digit I skipped was 7. Luckily, there was a digit I skipped, right? It's not allowed to be a 1. It's not allowed to be a 2. It's not allowed to be a 3, etc. The only digit it's allowed to be by basic Sudoku rules is a 7. Now, if you remember from my intro, if you watched it, every cell needs to have a digit in it. We need to place a 7 in this cell. Otherwise, it will not be able to have a digit in it. If I try to put the 7 elsewhere, like here, now this cell can't be any digit, which is bad because we need to fill a digit into it. We're just gonna automatically break some Sudoku rule if we do that. Therefore, we'd better put the 7 in here now so we don't accidentally do that, right? So it's great. We get a digit. It's called a naked single. Anytime there's single in the name of a technique, There's just two, naked single and hidden single. That means we can place the digit. All right, so hopefully that's clear why that's a 7. Yes, there are other places we could have put 7 in the row, column, and box, but looking at the cell itself, that's why I use the word naked 7. Looking at the cell itself, it nakedly must be 7, ignoring other context other than the digits that are looking at it. All right, now that that's a 7, what we want to do is I have the red marks on to kind of assist with visualizing that. All the red marks are doing is they're going, hey, you put a 7 there. Okay, well, now this shouldn't be 7 anymore. It's not using the solution to the puzzle, as you can see, because it still says, hey, one of these two could be 7. If it knew the solution, it would make all of them red except one, because it would tell me which one was 7. That would be kind of boring. I wouldn't have that option on if it were an option. I don't know why anyone would, because you'd basically just pencil every cell, and then it would tell you what digit goes there. But all this is doing, so even if I put the 7 in the wrong place, it's still going to turn red. If I put it in the wrong place, it's still going to turn red. We know these aren't 7 because the 7's here. All it's doing is it's saying, hey, you have that 7 there. Maybe you should look at this because it can't be 7 anymore. Because now the rest of the column, the rest of the row, and the rest of the box cannot be 7. If we have a 7 penciled in any of those cells, again, this is just part of scanning. We see that the 7 looks at these 20 cells, right? And so none of those 20 cells can now have a 7 pencil marked in it. So we can remove this 7 corner mark. When we do so, we want, because the corner marks are relating to the box, we want to look to see where else in the box can still be 7. It's reduced to 2 places. That might be interesting. It's not as interesting as only one place. In this case, it's not very interesting, but it's still useful to have eliminated that. All right, so we placed that 7. And the way we placed it is I looked at this row, which was reduced to 4 open cells. And I noticed that because 1, 4, 6, 7 were the only digits left, this cell saw a 1, 4, and 6, and therefore could only be 7. So we found a naked single that way. But there's more we can find. Remember that 6 was the last digit I was looking at. I noticed this first, but look, we also have this 6 here, which eliminates 6 from these 2 cells. It sees these 2 cells in the box. So there is only one cell in this row that can be 6, and that's this cell right here. This cell we filled with a 7, but also it couldn't have been 6 anyway. This 6 sees these 2 cells. These can't be 6, so it would repeat 6 in the box. So this is the only cell in the row that can be 6. This is called a hidden single. Now, why isn't it a naked single? Well, I could put a 1 here, right? There's no 1 in the column. There's no 1 in the row. There's no 1 in the box that we know of. So according to this cell, it can be more than just a 6. So it's not a naked single 6. The hidden single is, in this case, dealing with this row. Hidden can apply to rows, columns, or boxes. Usually, if you want to avoid confusion, you might specify that it's a hidden single in the row. You would specify that you're looking at the row because you could be looking at a row, column, or box. Sometimes it's a hidden in more than one of them. In this case, it's not. But in this row, we have a hidden single 6. Hidden is referring to the 9 cells of a row, column, or box, and single is telling us that there is only 1 cell remaining that can have a digit. Now we know that this row needs a 6. If I do not put a 6 here, if I were to put the 1 here, for example, there's no immediate conflict, but there is, because I am no longer able to put a 6 in this row. I can't put it here, and I can't put it here. And those are the only 2 left open spots. You can't replace any of these digits. Can't replace this with a 6. Even if I wanted to, we know it has to be 7. So this ends up being a 6. We can confidently place that 6 because it is a hidden single in the row. Now, if you only do hidden singles and naked singles, you can solve any easy New York Times Sudoku. The easy Sudoku solve with just those 2 techniques. So if you're still struggling on easy, look for naked singles, look for hidden singles, and you will solve them 100% of the time. For the mediums and hard, you do need more, and we'll go over what those are. All right, but there are 2 open cells left in this row, and one of them is a 1, and now this one here sees this cell. It looks at this cell, sees, synonym to look, unfortunately. I use some different words to mean the same thing. I apologize, but it's not going to change. I'm too used to saying different words. But the 1 looks at this cell, eliminating 1 from here. So actually there's only 1 place for 1 in the row. So we have a hidden single 1 here. And then the final digit is a 4, and that's a hidden single 4. But actually, really, when you have 8 out of the 9 placed in the row, or a box or column, in this case, this row has 8 out of the 9. We call this a full house just because it's both a naked single and a hidden single. You can take your pick of what you want to call it, or you can call it a full house, or you can just say it's the last digit for the row. You don't need a fancy name for it if you don't want to. So we can place the 1 and the 4. Another thing I could point out, though, is that this was also a naked single 4, because it sees 1, 2, 3, 5, 6, 7, 8, 9. Notice most of them are in the row. But yeah, this is also a naked single 4. So I could have resolved this with hidden single 1, hidden single 4, or full house 4. Or I could resolve this with naked single 4, full house 1. Either way, you get the same answer, which is good. All right, so we just got a bunch of info about this row by just going, hey, it only had 4 open cells. Maybe there's something interesting about it. Well, there was something very interesting about it. Now that we got all those digits, we want to rescan for buddies, just in case we missed any, right? So the 7, 1, 4, and 6. Ideally, you could actually scan for these as you go, but it doesn't really matter. If you know that you're focused on this row and you're going to be filling digits, you can just make sure you go back and scan all of them. Let's scan them in a numerical order. So is there another 1 in the band? No, there's not. Is there another 4 in the band? No, there's not. Is there another 6 in the band? Yes, there is. So all these 6s look in. We can put a 6, corner mark 6 in one of these two. Is there another 7 in the band? Yes, there is. Notice what's nice about the digits being blue that I placed to distinguish them from givens is it's a reminder of what I've discovered versus what was given. We already looked at all the givens, so I just had to look at the blues of what we discovered. This 7 looks down. So 7 is corner marked here. Now, this is one of the most difficult spots in a medium that you will have. But if you can spot it, it is very important to do so because it's going to significantly improve your solve rates. This is called a hidden triple. Now, if you recall, I have used the hidden word before for a single. Now, a hidden triple, the triple part hopefully implies the number 3 to you. And so if single meant 1 cell, triple means 3 cells. You can also have a pair, which would be 2 cells. I don't know why it's pair versus double. So we go from pair to triple instead of double to triple. I don't know why. Those are just the words that we're used to. So anyway, this is a triple though. 3. So what does 3 mean? Well, it's 3 cells and it's also 3 digits. A single is 1 digit and 1 cell. A pair is 2 digits and 2 cells. And a triple is 3 digits and 3 cells. So what do I mean by that? Well, look at what these corner marks are telling us. The 7, 8, and 9 corner marks. Think about these for a moment. Let's take them one at a time. The 7 is telling us, the corner marks are telling us that within this box, the 7 is in this cell or this cell. It will end up in one of them. Exactly one of them. Not none of them, not both of them, obviously. It'll end up in one of them. This will be 7 or this will be 7. In our solution, if you were to look at the solution, like if you went to go to the end of the video if you want, or if you solved this already yourself, look at the solution. One of these is 7, I guarantee it. All right, the 8's telling us that one of these 2 is 8, and the 9 is telling us that one of these 3 is 9. Okay, so they kind of have to share that territory, right? They need to share those cells. You can't put 7 and 9 in the same cell, so they're gonna have to split it up between them. Now, how much wiggle room do we have to do that, right? Well, there's 3 digits, the 7, 8, and 9. That's 3 unique digits. And there are 3 cells. How many cells do 3 digits need? They need 3 cells. Therefore, these cells are going to get filled with 7, 8, and 9 and nothing else. Because the 7, 8, and 9 need to split up this territory. They need to split these cells up between each other. And there is only one way to do it, which is each one gets 1 and then there's none left. So as an example, maybe the 7 gets this one. And now you'll notice that now there's only one place for 8. And now you'll notice there's only one place for 9. So that's one way this could resolve. But it doesn't necessarily resolve that way. We could end up with the 7 here. Then in which case we have two choices for 8, 9. Maybe this ends up 8. Maybe that ends up 9. Maybe this ends up 8 and that ends up 9. All right. So there's a few options. And you could go through them all if you wanted to. But ultimately, these cells can't be anything but 7, 8, 9 because the 7, 8, 9 need to use all 3 of them. And that's called a hidden triple. And a hidden pair or hidden triple, what they're always going to do, and actually if you think about it, the hidden single does the same thing. But what it's going to do is it's going to remove all but the mentioned digits as options from those cells. So we thought that these could be 2 or 3 as well, especially like this cell, this cell here, right? 3, no, because it sees a 3, but 2, right? We thought this cell could be 2. Right? If I fill a 2, it doesn't turn red, right? There's no 2 in the column. There's no 2 in the row. There's no other 2 in the box yet. Why can't it be 2? Seems like 2 is a perfectly viable option for this cell. Well, the answer is, where am I putting 7, 8, and 9 in this box now? I can put the 7 here and the 8 here, but now there's nowhere for 9. Okay, well, let's replace one of them with 9. Well, now there's nowhere for 7. Okay, replace one of them with 7. I can't do that one. All right, how about this one? I'll place that with 7. Nope, now there's nowhere for 9 again, right? That's always going to keep happening. We've proven it's going to happen because we need 3 cells for them, and we left only 2 cells for them. So that would be bad. So these can't be 2 anymore. This one already couldn't be 2 or 3 or 7, right? So some of them that doesn't affect, but like this cell here can't be 2 anymore. This cell here can't be 2 anymore. That's important. So if none of these are 2, then that means the 2 in this box can no longer go down here. It's not in any of these cells, so the 2 in this box ends up here. Now I'm going to do something additional here instead of just leaving these corner marks behind, is I'm going to use center marks. Now what a center mark is used for is to give the list of digits that that cell can still be. So if I wanted to, let's just use this top left cell as an example to get out of the scope of what we were talking about, just generically. This cell, I could fill in 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I could say, well, it's not a 1, it's not a 2, it's not a 4, it's not a 6, it's not a 7. But it could be 3, 8, or 9. And so then I could leave 3, 8, 9 in there. And I could go cell by cell and I could center mark all of them. That's very boring, don't do it. And it's just going to clutter your grid, and you're not going to remember why you center marked it or that it's useful in any way. And you're going to have to, you're going to end up scanning your center marks instead of scanning your givens. And I do not recommend that. That's boring, and you're going to miss things. It hides the important things. You've created needles and haystacks. Let's only mark needles, and then we don't have to worry about the hay getting in the way. So that's what center marks would represent, that this cell ultimately will be a 3, 8, or 9. It doesn't tell us anything about the box, doesn't tell us anything about the row or column. It's talking only about this one individual cell, and it's saying, if I were to look at the solution to this puzzle, there will be a 3 in here, an 8 in here, or a 9 in here, guaranteed. I don't know which one, but it's going to be one of those 3 and not any other. So that's what we're going to use center marks for. So down here, we proved that these cells are only going to be from 7, 8, 9. So I can actually convert my corner marks to center marks and say that's what's going to end up in these cells. This will be only 8, 9, 7, 9, 7, 8, 9. Now, if you look, this is going to look like a triple as well. And this is what we'd call a naked triple. We found it via a hidden triple, and actually because we found it via a hidden triple, the fact that it's a naked triple is usually not super useful. It could be though, but in this case, I'm not sure that it is. It depends. It might be useful vertically, for example, that these cells were reduced. But what this is doing is it's reminding us that these are only from 7, 8, 9. And so you could see this as a naked triple. We'll go over that a little bit later. But now we also have this 2 and 3 remaining. You could see this as a hidden pair, or just the last 2 digits that remain in the box. And so we're going to use 2, 3 there. Okay, so now this is a naked pair, and I'm going to explain that. We found that by excluding the 2 from these 3 cells, because this was a hidden triple. So we end up with this naked 2, 3 pair remaining. For every hidden, there's a naked. And if you sum up all the hiddens and nakeds in a row, column, or box, you end up with the number of remaining open cells. So in this case, a naked pair plus a hidden triple is adding up to 5. 2 plus 3 is 5, and there were 5 open cells. If you want, you can consider all of these singles, and so that's 4 more, and that adds to 9, right? So what we could have done is found this naked pair instead. So I'm actually going to erase this, and I'm going to explain the naked pair, because you could find it either way. Let's just pencil what this cell can be. It can't be 1, it could be 2, it could be 3, it can't be 4, 5, 6, 7, 8, or 9. So it's only 2 or 3. This cell here, it can't be 1 in the box, right? It could be 2, could be 3, it can't be 4, 5, 6, 7, 8, 9. So this is also 2, 3. So what does that mean for us? Well, in this box, they both share the same box. They're in the same box as each other. They're also in the same row. We'll go over that later. They're in the same box as each other. Because they're in the same box, we cannot repeat the 2, we cannot repeat the 3. So one of these needs to end up, these need to end up different digits from each other. What are the 2 different digits they'll end up as? Well, sometimes we don't know. Sometimes there's a lot of options. But here there's not options. There's only one option. One of them will be 2, one of them will be 3. Because there's no other digits these can be. Right? If I tried to not make one of them a 2, then they would both have to be 3, right? That would be the only option left for both of them. If I tried to make both of them not a 3, then now they'd both be a 2. So one of them will be 2, one will be 3. It will resolve like this or like this, and that's the only option. So if the 2 and 3 are going to end up in these 2 cells, and they share this box, that means that they look at these 3 cells. They see these 3 cells and say, well, they can't be 2 or 3 because the 2 or 3 is up here. We can't repeat the 2 or 3 in the box. Hopefully you see how that works. So actually these can't be 2 or 3. So what can these be? Well, in the box, so the box already knows where 1 is. We know where 2 is. It's in one of these 2. Most importantly, it's not here, right? We know the 2 is not here because the 2 is here in the 2-3 pair. We also know the 3 is not here. Even ignoring this 3, if we wanted to, we would see that the 3 in the box is up here. You also don't have to ignore that 3. It's fine. There's a 4 in the box, there's a 5 in the box, and there's a 6 in the box. So we know where 1 through 6 is. So 7, 8, and 9 are the only ones left, and we can clean up this 7, and we can clean up this 8. You may notice this result is exactly the same as us finding the hidden triple and then discovering because of that there's a naked pair here. Taking a drink because I'm thirsty, but also let that sink in. So that is a really important concept, that it's 2 sides of the same coin. The hidden and the naked are 2 sides of the same coin. Technically, a naked 7 is because you have a hidden octuple in the rest of the row or column or box, right? In this case, it was a hidden triple. We had a hidden triple 1, 4, 6 in this row. This 1, 4, 6 said not here. Therefore, there was a hidden triple 1, 4, 6 here. If you want to think about it that way, right? For every naked, there's going to be a hidden for the remaining open cells. So for this naked 2, 3, there's a hidden 7, 8, 9. For the hidden 7, 8, 9, there's a naked 2, 3, right? So hopefully that's understandable. I know it's a difficult concept, and the word pair and triple are sometimes used without specifying whether it was naked or hidden, and people get very confused why sometimes it works one way and sometimes it works another way. It's because they are 2 distinct techniques, 2 distinct results, as a result of them being different sides of the same coin. Okay, so this 2, 3 though, it's doing more work because they happen to share the same row. They didn't have to in order to affect the box. Like it could have had a 2, 3 pair. Could have had a 2, 3 pair naked pair here, giving us a 7, 8, 9 hidden triple here. But in this case, they did happen to be in the same row. And so I need more water. I'm sorry. Because they're in the same row, we know where the 2, 3 is for the row, which means these cells cannot be 2, 3. So for example, a result of that is because there's a 2 in here and we have this 2 here, there's now a buddy for this 2. We don't know exactly which one of these it's in, but it doesn't matter. It affects this box in the same way. This 2 looks down. So we can corner mark 2s here, actually. Isn't that neat? All right, so we've done all of this just from, remember that we found all these digits, and then we rescanned buddies. And I believe I found the buddy for the 7, and we already had the 8 and the 9 buddy down here. So we found the 7. It feels like ages ago, probably was about 10 minutes ago at least. But that gave us the hidden 7, 8, 9 triple. Normally in a hard solve, I would have gone hidden 7, 8, 9 triple, and we would have been off to the races, right? I wouldn't have sat here and explained it all, but I think it's important to understand this concept. And I think this was a good opportunity to explain it because this is a really good example. So we're going to re-look at the rest of what we were scanning. We found the buddies, but there's more to basically follow up. We call it following up when we're going back and rescanning what we already scanned. Or more importantly, we placed some digits or we found some information. Let's follow up on that information and find more about it. Don't just put the 2, 3 in and go, oh, that's neat, let's move on. No, look at the consequence of the 2, 3, right? So I told you to look for filled box rows earlier. We didn't have any. Now we have this whole row filled. So really what we want to do is let's focus on this first. Actually, is there anything to find for these? There's nothing to find for these, unfortunately, but what we want to do is we want to look to make sure that there aren't any digits outside of here looking into the box. But because the buddy system is going to do the same thing that we already did because this row is completely filled. So we're not going to find anything. So we'll do it when we actually can find something. But also I said to look for rows or boxes down to 4 or fewer open digits. Well, this box is now down to 3 digits. So we want to think about it. And my recommendation for center marking, by the way, is only if the cell is reduced to 3 or fewer digits. And only if you had a reason to center mark it. In this case, the reason is that it's in a very restricted box. So if we wanted to, we could just immediately center mark. But what I like to do is I like to think about the digits one at a time first. Even so. And so what are the 3 digits that we need? We need a 1. And I'm noticing this one looks in. So actually 1 is reduced to one of these 2 cells here. So we can corner mark the 1s here. Now, this is something I want to follow up on right away. And this is something I haven't explained yet. Yes, there is more to explain. I've explained, hopefully, yeah, at this point you understand the naked single and the hidden single. The naked pair, maybe the naked triple, you can extrapolate the naked triple from the naked pair, but if we do get a naked triple, I'll explain it in more depth because some people misunderstand the naked triple and its requirements. They over restrict the requirements on it. But anyway, we got the naked pair and naked triple. We've got the hidden pair and hidden triple. There are only two techniques that you still need to be able to solve any medium or hard New York Times Sudoku is pointing and claiming. And they're very similar to each other, just kind of reversed. We found pointing here, so let's go over pointing. So in this box, we've corner marked 1 in these two cells, which means 1 can only be here or here. 1 will be here or here. You may notice this is going to feel very similar to finding a pair, but it only requires 1 digit. This box needs a 1. It'll be here or here. There is going to be a 1 here, or there will be a 1 here, and those are only 2 worlds. Both of these cells happen to share a column, right? They're in the same column as each other. And so wherever the 1 ends up, the rest of the column is going to see that 1, and we'll have 1 eliminated. So pointing is basically if we draw a line here and we imagine an arrowhead at the end of each line, it's pointing in both directions along the column saying no more 1s. I need the 1. The box is saying I need the 1 for this column. I need a 1 and it's going to be in this column. So the rest of the column cannot be 1. We already knew these couldn't be 1 because of this 1 in this box, but these cannot be 1 anymore. We also have this one down here looking in and this one looking in. So I recommend following up on pointing even if you haven't scanned that stack yet or the band. I recommend following up anyway because it's harder to see later. And often it's interesting. In this case, it's very interesting because we have a hidden single 1 in this box. None of these cells can be 1 anymore. Remember, these say these can't be 1. This one looks in, this one looks in, this isn't a 1, so this is the only place for 1. Now we want to follow up on that 1. We have a buddy for it. They look in here. This one looks up. We can place this one. I have just placed so many 1s, I'm going to just continue following up on them, right? I have these 2 1 buddies. I can place this 1 here. Now, before I place this 1, I am noticing that this cell has a corner mark 6 in it. When I place the 1, that corner mark 6 goes away. If you forget, luckily Sudoku Pad, anytime, you can just press delete once to remove the big digit, and it remembers what you had penciled in it before you place the big digit in it. So if you want to remind yourself, yes, there was a 6 corner marked in there. And so what we need to do is we need to look in the box for how many 6 corner marks remain. There's only 1 6 corner mark remaining in this box. So this is a hidden single 6 in the box based on our corner marks. So we can place the 6 here, which is placed to 2. So now there's only 1 place for 2 in the box, and we can place the 2 as well. This 1 also, if we scan its row, we can see that we had a 1 corner marked here. Well, it can't be 1 anymore, and the red marks are very, very helpfully reminding us of that. And so now there's only 1 place for 1 in this box. And now what I'm going to do is I'm going to say I just placed, I think, most of the 1s. I placed 8 out of the 9. Whenever you have 8 out of 9 placed, the 9th is always placeable. So these all 1s look in, and we can place our final 1, and we're done with 1s. So if you find yourself doing a chain of a bunch of a single digit, just try to finish the digit. You can double click the digit to see everywhere it is. It can be helpful. Okay, so we just got a bunch of stuff that we may need to follow up on. But I'm going to backtrack to this box. I was looking at the digits in this box. I stopped at 1 and I found a bunch of stuff. So we're gonna now list the other 2 digits. They're the 4 and the 5. Do we see any 4s or 5s helping? No. So I'm just going to pencil 4, 5 here. But we just got a bunch of digits here, right? The important thing is this box is now down to 2 digits. It's also this row that's down to 2 digits. And you might say, well, I see 4 open cells. These aren't open for the row. These are 2 and 3. It doesn't matter how they resolve. The row doesn't care. These are closed. These are the 2 and the 3. So these are the 2 other digits, which is also the 4 and the 5. But this 4 tells us the order. So that's 5, that's 4. Now we've almost finished this entire band, which is really awesome. We've only scanned that band and done some follow-ups, and we have finished this band entirely, which is really cool. Okay. And if we had used this 2 earlier, we would actually resolve this 2, 3 as well, but let's not worry about that. I just wanted to point that out. Anyway, now that we've finished this band, it's safe to move on to the next band. Something I'm going to double check, right? I actually already did when I looked up here is, was there anything that these placed 1s did that maybe I should rescan? Like maybe it filled a box row, maybe it caused a buddy that I didn't realize, or maybe there's a row or box down to 4 or fewer now, and none of those checkboxes went off. So I just moved on. So let's do this band now. Do you remember what we do with bands? We look for duplicates. Does this 2 have a duplicate? I'm going to ignore 1 because I know the 1s are done in the puzzle. If you notice you have all 3 in the band, you don't need to worry about it. It's not going to have a buddy. Well, it's going to have 2 buddies, and that's not helpful. This 2 does not have a buddy. This 3 and 9 do not have buddies. So no buddies in this band at all. Any filled box rows? Nope. Any rows or boxes down to 4 or fewer? Nope. Okay, well, let's start scanning stacks then. We're going to do the exact same thing with stacks that we did with bands. Remember, stacks and bands, rows and columns, they're basically equivalent. You can rotate the entire puzzle and they swap. So the exact same thing we did with rows and bands, we're going to do with columns and stacks. So we're going to start here. And we're always going to find a buddy in this middle box, right? So 1s are done. We have the 5 and the 6. So let's do those one at a time. If you want, we could do them in numerical order. That might be easier. So let's just do 2, 4, 5, 6. So the 2 has got a buddy. This 2 looks in. 2's in one of these 2. The 4 has a buddy. It's a 4 in one of these 2. We have the 5, found the buddy. This 5 also looks in. We can place the 5 here. When we do so, follow up on the band. We have these 2 5s now. They're buddies. There's a 5 in one of these 2. Now, this is another, if this wasn't the hardest spot, this is. This might actually be the hardest spot. If you've watched a few of my videos before, I want you to think about what just happened here. Do you see it? All right, pause if you need to, if you need more time, but I'm going to go over it now. Whenever I corner mark or find a pair in a box, I am scanning perpendicular to that. So for example, we corner mark the 5s in this row, perpendicular to that. So I'm looking at the 2 boxes below it because these are lined up in the row. I'm looking down. If they were lined up in the column, I'd look left, right? So I'm looking down at these 2 boxes and I'm specifically looking to see where can 5 go in those boxes. Luckily, I already have it marked in here. If I didn't, I would still try to scan for it. Because if you find this, it's really, really important. Okay. So where can 5 go in this box? It can go here. And that lines up with these 5s. Specifically, these 5s are avoiding column 8, and these 5s are avoiding column 8. So poor column 8 is having trouble finding a 5. It's not in this box, and it's not in this box. So what does that mean? It means it's in this box. So it means that column 8's 5 is limited to these 3 cells. And actually, we have this 5 helping out, limiting it to these 2 cells. So I can corner mark that. And you might say, earlier you said you only corner mark for boxes. Why are you corner marking for a column? Well, very good question. I can, because these 2 are in the same box. These are both in box 9. And this is our final technique. It's called claiming. We found the claiming via the lined up 5s, but we could have discovered it in any way as long as we analyzed the digits, the open cells in this column, and saw that 5 was limited to these 2, and those 2 happen to be in the same box. If you find the lining up, it's always indicative that you are going to find claiming, or a single, even better if it's a single. But in this case, we found claiming. What is claiming? Well, column 8 is claiming the 5 from box 9. Specifically, it's going to seem very similar to pointing, but it's opposite, right? The 5, there needs to be a 5 in column 8, and that 5 needs to come from box 9, because the 2 options we have happen to both be in box 9. Remember, it's almost coincidental that it happens, but if you notice it, then it's very powerful, right? Because it's coincidental, that's what makes it powerful. That's something that's going to be very consistent among Sudoku. The more forced a discovery was, the less powerful it is in terms of eliminations. If it's extremely coincidental, it's going to have the most eliminations. I don't know if that makes sense to you. I hope it does, but maybe that'll click something. Because this is coincidental, it actually is useful, because we already know these couldn't be 5, unfortunately, but let's say that we ignore this 5 here, and we had a corner marked 5 here. It's going to claim the 5 from these 2, the 5 needs to be in this column, so it's not going to be over here. Some people will see this as an X-wing. I don't like seeing it as an X-wing for 2 reasons. One is the X-wing is a real technique that spans 4 boxes, not 2 boxes. This is a degenerate X-wing because you can notice it just by looking at one single column. But also you can find this even if it's not specifically an X-wing, as long as the 5s in this box and the 5s in this box happen to avoid column 8. This technique applies. So it's not really an X-wing. This happens to also be. You could view it as an X-wing if you want. If you know what an X-wing is, you'll see how that works. And it does the same thing. These are not 5. This isn't 5 also. But the important thing is actually we've discovered that this cell can't be 5, which is not a Not a trivial discovery. We had to use claiming to find it. We have discovered that this cell is not 5. And we're hoping that these corner mark 5s are going to help us remember that, because we have not center marked this cell. And I don't recommend just randomly center marking it just so you can remember it's not 5, especially if it still has 4 or more open digits left. And I've done a quick scan here. I've seen it can't be 1, 2, 3, 6, or 9, and also not 5. That's not enough for me to center mark. But these corner mark 5s are going to remind me that it can't be 5. Okay. So we've discovered that, but remember we were following up with these 5s. So the 5 ended up here. We followed up more and found these claiming 5s, which is very helpful. Now, did that fill up? Did this 5 that we got fill up a box row? No. Did it cause a row or box to be 4 or fewer? No. Okay, so we finished following up with that 5. Because I was going in numerical order, I remember we did the 2, 4, and 5. We now need to do the 6. They look up. 6 is in one of these two. Okay. This is going to be a long one. I've done a lot of explaining. I hope that this is helpful and not boring. Okay. So we have now done the buddies for this stack. What else do we look for? We look for filled box columns, but we're ignoring these. This box is done. You don't need to look at filled box columns and boxes that are already done or already already completely marked up, and you figured out all the corner marks in it. The filled box columns only help you discover additional corner marks that you didn't already discover in the box. So not going to be helpful. No other filled box columns. Any columns or boxes down to 4 or fewer. I'm going to start with the fewest, which is this column, which has 3 remaining. Think about the 3 digits first. 3, 8, 9. We're looking for 3s, 8s, and 9s. I see this 3. Here we have found claiming again. Do you see it? We've analyzed this column, and we have discovered that this can't be 3 for random reasons. The more random the reason is, the more interesting the result is, which is that 3 is limited to these 2 in the column. Those happen to share box 1, so we can corner mark them, and that is telling us that these can't be 3 anymore. Okay, but also these 3s, so if this can't be 3, none of these are 3, this 3 looks down, this 3 looks in, we can corner mark 3s in this column as well. So that's the power, is that because we limited it here in that weird way, it also limited it, you can see it limiting it in this column, right? This can't be 3 because the 3 is over here in the box, and so the 3 was limited to these 2 in the column as well, or you can see how it's limited in the box. There's more than one way to discover the same thing, and that's pretty fun. Hopefully they all agree. If they start disagreeing, that's when you have problems. You probably made a mistake somewhere if they disagree. Okay. So other than the 3, we also need 8 and 9. I see this can't be 8. So that's not super interesting though. So I'm just going to fill 3, 8, 9 and all 3, and I'm going to clean up the 3 and the 8. And we have now penciled this column. There's not much more to find, but that 3 is interesting. So I'm glad we found it. All right. Now we can decide if we want to do, I don't think we can do any of the boxes. So we can continue with the columns. I'm just going to go in order. So we need a 4, which we already have corner marked. So nothing more to discover there. We have the 5. We need a 6, which is corner marked. We need a 7. Now the 7 is immediately suspicious to me. Unfortunately, it doesn't pan out, but it's suspicious because I have the 7's corner marked this way, which is informing me that this can't be 7 already. So I'm looking down here to see if 7s are restricted, and unfortunately they aren't. So we need the 4, 6, 7, and then also the 9. And I'm looking to see if 9's restricted. I see this 9, but nothing else. Now, because I have the 4's cornered here and the 6's cornered here, I know that these can't be 6's and these can't be 4's. So these are worth marking because they're down to 3. So I'm going to mark them all. I'm going to mark 4, 6, 7, 9, and I'm going to clean it up. This can't be 4. Neither of these can be 4. Neither of these can be 6. We knew that. This sees a 7. This sees a 9. We noticed those both as well. All right. And if there was ever anything that cleaned up when you center marked that you didn't notice on your first pass, take a closer look at that digit again because it means you missed something. All right. Now we're going to do this column as well. It is down to 2. We already have the 2's marked. 3, we have them marked. If we have them marked, we don't have to think about them further because we already thought about it when we marked it. We've got 2, 3, 7, and 8. Now, here's what I'm noticing. This cell can't be 2, 3, or 8. Because I noticed that we have the 2, 3 marked down here, which means it's not here, right? The 3's claimed this cell. So actually the claiming is what caused this to be a naked single. But we know it can't be 2, 3, 8. The 2 and 3 for the column are down here, and this can't be 8 because of the 8 in the row. So this is a naked single 7. Can't be anything but 7, so we're going to place the 7 there. Remember, if you think it can be 3, it can't. The 3's over here for the column. It claimed the box. That's what eliminated 3 from here. You can see it down here as well. So that's our 7. We're trusting our markings, right? That's not a 7. So that leaves a 6, 9 naked pair here. That 6, 9 naked pair is huge. Let's look at how it affects the box, right? The 6 and 9 are here for the box, so they're not here. Specifically, the 9's not here. We can eliminate it. That resolves our 3 and 8. That 3-8 resolving resolves our 9 here. The 6-9 pair also resolved the 9, remove the 9 from there, leaving a 4-7 pair here. That means this is a 2-3-8 triple. Clean it up a little bit. We don't need those corner marks anymore because we have the triple filled. All right, look, this stack is almost done now, just from focusing on it. We're going to obviously move on to the next. We placed some digits, so we need to make sure we followed up on those placed digits in the bands before we move on to the next stack. I sort of deferred it because I knew we were getting a bunch of stuff. But now we need to make sure we follow up. So I'm looking at all of my blue digits here because I don't remember which were placed. Just double checking. The 1s are finished. 7s are finished. 5s we have marked. 3 and 8. 3 has no buddy. The 8, though, has a buddy now. This 8 looks up. So 8's in one of these two. Okay. Now, any rows. This is a filled box row, by the way. But again, we know everything about this box. Finding more corner marks in this box is not going to be helpful. We found them all already. It's just the 6-9 pair. So not helpful. But rows or boxes down to 4 or fewer open cells. Yes, we have this row now down to 4. So think about the digits. It's the same thing we've been doing. 2, 4, 6, 9. So we think about 2, 4, 6, 9, one at a time. We're scanning for 2s, 4s, 6s, and 9s. I see that this cell sees 2, 9. So if it's not 2, 9, then it's only 4, 6. This one can't be 6, so it is 2, 4, 9. And this cell can be any of 2, 4, 6, 9, so we are not going to mark it because that is 4 digits left. Something I'm looking for is, because we know that this is all 4, we know we don't have any hidden singles. And we also know that nothing's restricted to a box. So kind of handy. It's unfortunate, but handy that we don't have to look more closely for that. But you can look if you want. You just aren't going to find anything. This is down to 5, so we don't need to mark it up. This is down to 5. This is still down to 5. Okay, so we also place digits down here, specifically the 9. So the 9 does have a buddy. And the 9 ends up down here somewhere. All right, we followed up. Now we're going to do this stack. 1s are done in the puzzle. Remember, a look at the 2. There are no known 2s in here. Maybe at some point you do notice this 2, but we're still going to pretend we haven't. Then we have this. Let's just look at the 1, 5, 7, 8. Look down here. 1s are done, right? But the 5 does have a buddy. Those look down. This 5 looks in. Puts a 5 in one of these two. Now you can look perpendicular and see that these line up, but we already have the 5 placed in this row. So that's actually what caused that. So unfortunately, it's not coincidental, so it doesn't do eliminations. I think trying to run that point home. The more coincidental the discovery, the more eliminations it usually makes. More with the stack. Any other buddies? The 7 or the 8? Nope. Okay. Any filled box columns? Nope. Any columns or boxes down to 4 or fewer. Technically, we should have already noticed all the boxes being down to 4 or fewer by doing the bands and following up on the bands, but it doesn't hurt to look. But this column is down to 4. Now it's time to look at it. So what are the digits? We need 3. And I'm looking around for 3s, right? I see this one. That's it. We need 4. And we need 8 and 9. So what am I seeing? I'm seeing that 9 can't be here. But 9 can be in plenty of other places. 8 be plenty. Okay. So the only thing I'm going to do is I'm going to look at the ones that saw something, right? And if you want, you can just fill it all out and then delete. So that's what I'm going to do in this case, just to show that. So we needed 3, 4, 8, 9. This can't be 3 or 9. So it's down to 4, 8. This can be any of them. And I'm going to double check my corner marks. The red marks don't tell you everything. They don't tell you about pairs. They don't tell you about corner marks, things like that. But we haven't discovered any restrictions on this. And then this can't be 8. We're looking for 3, 4s, 9s, right? You always want to double check the red marks. Don't just trust them. You can trust the red marks in terms of that those are eliminated, but you can't trust that it's the only things that are eliminated, right? You got to double check your corner marks. Like, for example, we know this isn't 5, but if I tried to put a 5 here, it would not show up red. Okay. So that was that column. No other column is down to 4 or fewer. So we are safe to move on to the next band. There was nothing to follow up on that we placed. Okay. So 3 and 9, we do have 2 3s looking up. This 3 looks in. So 3's in one of these two. We're getting pretty close to a hidden quad, but we don't have it. We have three digits that are restricted to 4 cells, which is unfortunate. It's an almost triple, right? Or but it's not. So that was the 3. The 9s also look up. And the unfortunate thing is 9 can be in all 3 of these. If 9 could not be here, we would have actually found a hidden quad, which would be fun, but that can be 9. And then we look for the 7 as well. These 7s look down. 7's in one of these two. All right, that's our buddies. Notice we didn't have to focus on this box at all. This box has a ton of givens. I could look at every given and see if there's repeats, but I didn't have to because I looked at the other two boxes and I compared it against that box already. Much faster. Any filled box columns? Yes, but again, this box, we don't need any more corner marks in it. We know what's going on with that box. Okay, any columns or boxes down to 4 or fewer? Yes, this column. So this is where if we hadn't already, this is where we would have noticed that this cell can't be 5. So we do have claiming 5s. You may notice that we also have claiming 4s here. So, but in general, we need 2, 4, 5, 6. This cell can't be 4 or 5. So this is down to 2, 6 only. And because this can't be 4 or 5, that means the 4 and 5 are down here. So we can quarter mark the 4s along with the 5. And then we're thinking about 2 and 6 as well. We see this 2 and this 6. So this is worth marking. It can't be 2. This is 4, 5, 6. This can't be 6 or this can't be 5 or 6. This is 2, 4 only. All right. Any other columns or boxes down to 4 or fewer? No. It looks like it's going to come down to the thing I noticed at the very start, which is fine. So we finished our first pass, and unfortunately the puzzle's not done. That means we have to do the second pass, or fortunately the puzzle's not done, so we get to do our second pass. Our second pass is going to focus box by box, and it's going to be internal to the box. We're looking at, are there restrictions in this box that are a bit more complex that I can't discover just by looking at the band alone or the stack alone? I'm looking for things that are going to require looking at both the band and the stack in order to restrict internally within the box. We're looking for corner marks inside the box mostly. And also we're looking to double check that we didn't miss anything about the box, that, we aren't perfect at following up. We aren't perfect at noticing. This is our opportunity to notice it now if we didn't notice it before. So this box here, I am going to notice we have a 6-9 pair. I'm going to double check that we have applied it. We have. That's not much more to find with this box because it's already fully marked up. Now this box. The thing that's triggering me to look for things in this box is that these are filled. There is a single row that's open and there's a single column that's open. That is always very suspicious. And this is something I would have looked at in my normal solves right at the start. But we're now looking for it now because our initial pass is looking at bands, kind of hyper-focused on bands, hyper-focused on stacks. Often that's enough. In this case, it wasn't. So what I'm going to do is I'm going to look at this row and this column, and the cells that aren't in the box. So the open row and the open column, I'm going to look here. And I'm looking for any digits that aren't in the box. So first of all, if it's not a digit, we don't care about it. And if it's already in the box, we don't care about it. So 8's in the box, 2 is not, 1's in the box, 7's in the box, 5's in the box, 1's in the box. Okay. So the 2, just finding that 2 is enough because there's only one open row. Because there's only one open row in the box, like a fully open row, fully open column, right? This intersection makes it a little bit more complex, but it's fine. So the 2 is looking into this box, and we're eliminating 2 from these 3 cells, and these can't be 2. So this is where I'm going to notice that 2 in this box is actually limited to these 2 cells. And that was something we maybe could have noticed from just the band, but it's not something where we have a buddy. Like it's interesting because it's the band causing eliminations in the stack. And so that's why I leave it for pass 2. I didn't want to mention it till now. But look, and also like we now understand pointing. We didn't understand it at the start of the puzzle. I hadn't explained it yet, and I feel like it would have been a little bit out of order. But I feel like this has been a really nice in order explanation of techniques. So the 2 is looking into this box, and these are not 2, right? And so it's eliminated 2 from an entire row, and these happen to be filled in a lined up way. Basically, the idea is there was only one open column. I don't know the best way to explain this, but the idea is the 2 looked in, it limited 2 to these 2 cells, and that's going to point and say the rest of the column can't be 2. So importantly, this cell can't be 2. If you want to understand it in another way, so first of all, the 2 is here, so it's not here, right, for the column? Because the box is saying the 2 is here. It needs it, so the column can't put it here. Look what happens if I try to put a 2 here. Well, this 2 looks in, this 2 looks in. These aren't 2. There's nowhere for 2 in the box. The box needs a 2, so we've broken the puzzle. So this cannot be 2. So it is, if it's not 2, then it's a naked single 3, and then that's now a naked single 2. All right, we just got this 3 and 2. Can we follow up on it? There's nothing with the band to follow up with, but we did do this stack earlier. So this 3, we look for a 3 here and 3 here. But we do hopefully at this point notice this 3 looks up, and it limits 3 to these 2 cells. Because we are focused on this box now. So we just place something in this column. follow up on what we were looking for. We were looking for digits in this row or digits in this column that were not already placed in the box. And so this 3 is now qualifying, and that's going to cause pointing again. This cell cannot be 3. That eliminates that 3 corner mark. And now there's only one place for 3 in the box, which is here. That displaces an 8 corner mark. Now this is a hidden single 8. That displaced a 9 corner mark, but there's still 2 places for 9, unfortunately. But we just got the 3 and the 8. Follow up. 3s are done for the stack. Our 3's done for the row. We have them marked here. This 8. How about 8 for the band? That's fine. I don't think the band would have been helped by that, but it doesn't hurt to look. These 2 8s do look down, though, and that lets us place this 8. Follow up. This can't be 8 anymore. So that's down to 2, 3. We filled a box column here, so we want to look 7. We're looking at these 2 columns, and we're trying to find any digits that aren't already placed. So 3 is placed. That's not a digit. 6 is interesting. I'm going to find them all first. Not 1, not 9, not 8. These are not interesting. Not 1, 7. 7 is already corner marked in the box, so we've already taken care of it. But the 6 now that this is an 8, this can't be a 6 anymore. So the 6 is looking down here. These aren't 6, and so that means one of the 6 is down here in one of these 2 cells. What have we found? You might say, well, we found a hidden triple. The 4, 5, and 6 are reduced to these 3. But if you say that, I want you to look closer. We have found a hidden pair. That's even better. Right here. If I ignore, let me delete the center marks. Oops, sorry. Let me delete the center marks and let me delete the 4s. If we ignore, so this is just pretending we're ignoring the 4s that are corner marked there, and we're ignoring the center marks. It's hay that's around our needles, right? The needles that we're noticing here are the 5 and the 6 are only in 2 cells in this box, and they're overlapping in the same 2 cells. This is a hidden pair. So the result of this is that we can convert those to center marks, and the 5, 6 end up here. Now, that means those 4s I removed. It was actually correct to remove those 4s from here because these have to be 5, 6. So now there's only one place for 4 in the box, which is right here. Isn't that crazy? We found that hidden 5, 6 pair. This 5, 6 pair also eliminates 6 from this cell. Notice it is a naked 5, 6 pair. We found it via the box, and it happens that this 5, 6 pair is in the column. Because it's coincidental, that means that this is a 2. Because it cannot be 6 anymore. It's the only place for 2 in the column as well, if you want to make that a hidden single. So this can't be 2. That places the 2 in this box. This can't be 2 anymore. There's a lot we could follow up on here, but we want to continue let's continue looking at this box because it's down to 2 digits here. It's the 2 and the 7, and this cell can't be 2, so we can place the 2 and the 7. That 2 gives us the 3. This 7 gives us the 4 and the 7. This 3 gives us the 8 and the 2. Because we just resolved a bunch of stuff. That seems more useful. Up here, so at this point, there's a lot to follow up on. We just got a lot of stuff. I recommend when you're this late in the puzzle, if you can notice a row, column, or box that has been reduced to really, really few cells, like this row is down to 2 cells, start with that. So in this case, there's only 6 and 9 left in the row, so we can center 6, 9 here. It's going to be the low-hanging fruit that we're looking for here. This box we reduced to 4 digits, the 4, 5, 6, 9. I'm looking at the consequences there. This can't be 9, so this is 4, 5, 6. And then this can't be, can this be any of 4, 5, 6, 9? It can, but I also noticed something else, which is we actually have claiming 4s in this row. I was looking at this triple and I was seeing, oh, this can't be 4. So therefore the 4 is in one of these 2, and that does claim. So the 4 actually can't be up here. So if the 4 is not up here, then this can't be 4. So this is 5, 6, 9 only. Oh, it's not a 6. I didn't notice that. So if the 4 is in one of these 2, there's actually a buddy 4 for it. This 4 looks up. That means 4 is up here somewhere. All right. Anything else to follow up here? I don't remember what we got. So let's rescan our blue digits here. It doesn't. If you didn't remember exactly what you got, it doesn't hurt to just rescan your blues real quick. Okay, I think we're good. This box is down to 4 open cells now because we placed that 2. We're down to 3, 4, 6, 9. So this can't be 4. So this is 3, 6, 9. This can't be 3. So this is 4, 6, 9. And we discover the same thing we already discovered, which is that the 3 and 4 are up here. Okay. Now, follow up on this band too. This row is down to 3 open cells. I'm going to start there. We have 1, 2. We need 3, 5, and 6. I'm noticing this sees a 3, and this is already marked not with a 3 because it sees that 3 and that 3. So 3 in this row can only be here. That displaces a 5. That gives us the 5 in the box as well, which resolves our 5 and 6 pair over here. This column, now this can't be a 3. So now in this box, there's only one place for 3. We can place it. Now there's only one place for 4. We can place it. Just following our corner marks here. This is down to 4, 8, 9 for the column. It can't be 8. So it is down to 4. Oh, it can't be 8 or 4. So it's a naked single 9. That gives us the 8 and the 4 here. All right. Now these two are full. These are full houses, right? There's only one digit left, so we can fill those. This is 6. It looks like that gives us the 9 and the 6 and the 7 and the 9. This 6 gives us 5, 9, 4, 6, which gives us the 9 and the 6, gives us the 4 and the 5. This box needs 7 and 8. That's 8. That's 7, and we're done. That was one of my longest medium solves, but only because I feel like I took the time to really talk about all the techniques in great detail. So I hope this was helpful for you. I hope you saw the long video and went, oh, cool, there's a lot of explanation, and not, oh no, it's an over an hour video. But I'm happy for any feedback on whether this was helpful. I'm trying to find a balance because I can't spend an hour and a half on this video every day. But maybe I can use this video to point to and say, hey, if you want to learn more, here's a good video for that. So cool. Well, I hope you enjoyed this. And if you did, then why don't leave a like, subscribe, and a kind comment below.